So welcome everyone to the first jam session that we will do as part of the search seminar series. Today, each person will have 15 minutes. Please hold anything but quick clarification questions until after the presentation. There will then be 5 minutes for questions, where then we will start the next presentation. At the end of all the presentations, I will leave the room open for any additional questions. Andre, take it away.
Okay, hello everyone. My name is Andre. I'm a PhD candidate at the University of North Carolina, Chapel Hill, and I'm on the market this year. I'm really glad to be here and have a chance to present main results of my job market paper, Consumer Data and Consumer Welfare, Evidence from the Hotel Booking Market. We live in the big data era. Tech giants like Google, Amazon, Expedia collect enormous amount of data about our preferences and behavior. I study how does it change markets and does it have positive or negative effect on us as consumers. Also, these tech giants claim they collect all this data to provide better service to customers via better product targeting. Recently, a discussion has been raging about should we allow them to collect and use our personal data. While the central part of this discussion is about privacy and human rights, it also brings economic questions. How does it change competition between firms that advertise on platforms? How does it change market prices? How does the consumer welfare change? These are the questions that I address in my research. There are numerous theoretical studies in this area, but still a lack of empirical ones. My paper fills this gap, being the first empirical research on firms' response to better targeting and its effect on consumer welfare. Let me provide a small real-world example of the list of hotels I get on Booking.com in two situations. On the left panel are presented results that I got being logged in into my personal account. While on the right panel is given the list of the hotels that Booking.com provided me when I anonymized myself as much as I could. You can see that in the left panel, Booking.com shows cheaper hotels on the top of the list because it observes my previous bookings and knows that price is an important hotel characteristic for me. But on the right panel, Booking.com also tries to do a good job in ranking and shows relevant hotels on the top of the list, instead of completely random ranking. But because I anonymized myself, the best that platform can do is to use the average consumer data. So let me state my research agenda in a bit more details. In this paper, I address how the market prices, consumer welfare, and the quality of the purchased product change if the platform can provide consumers better product rankings based on personal consumer preferences. I compare market outcomes in two different cases. In the first case, platform provides a common ranking to all consumers based on the aggregated data of all consumers' preferences. And in the second one, the platform provides the personalized rankings of products to consumers based on their personal preferences. But why ranking should matter at all? The key component is that the consumer have to incur such cost to learn product quality. In many markets, consumers are initially uninformed about the quality of the available products. They may conduct a costly search to learn about product qualities. And in many cases, this search are facilitated by information intermediaries, which provide rankings of products. Due to the presence of the search frictions, consumers explore not all products before making purchase decisions. As a result, change in the platform's ranking mechanism lead to a change in consumer demand function, since consumers are more likely to explore products which are on the higher positions in the list. Moreover, this demand change affects firm pricing strategies. This last aspect is missing in all previous empirical research. So it's well studied in the literature and empirical literature as well that a better ranking helps consumers easy and fast to find better suited products, reducing search expenditures and procuring a better product match. However, if consumers change search behavior, in equilibrium, sellers also change their behavior. With a better ranking, consumers find well-suited products high in the list and have low incentives to search further, which shrinks their consideration set and changes the demand elasticity, which in turn relaxes competition between sellers and changes their pricing strategies. Thus, the effect of better ranking on consumers' welfare is ambiguous without additional analysis. This paper is the first empirical attempt to estimate the equilibrium model in such settings. Previous empirical works do not model firms' strategic pricing response on the change of the platform ranking mechanism and estimate only the welfare effect due to the change in consumer search and purchase behavior, While my approach allows also estimate how market prices change due to the different rankings and provide more accurate analysis of effects on consumer welfare. Let me tell briefly about the data provided by Expedia that I use in the study. The data set includes around 200,000 consumers and provides the ordered list of the hotels and their characteristics, including prices that each consumer sees after she or he search for a hotel on the Expedia site. Data set includes information on what hotels consumer clicked and to get more information about the hotel and what, if any, purchased. In short, the data set contains consumer search and purchase behavior and the characteristics of the hotels that consumers search over, including the positions of the hotel in the list shown to the consumers. So my main approach consists of several main steps. First, I construct and estimate consumer demand, consumers' demand using the model of optimal sequential consumer search based on the classical Wiseman model. Next, I estimate demand function to analyze. I use this estimated demand function to analyze hotels' competition and recover hotels' costs. After that, I run simulations of different ranking systems. Permutations. So the main idea is that permutations of hotels' positions lead to change in their demand functions, which change hotels' pricing game, and that lead to a change in price, and finally to the change in consumer welfare. To model the demand part, I use a classical Wiseman model. Consumers' optimal search strategy is characterized by the utility Uij, so that is the actual utility that consumer I derives purchasing the product J, and the reservation utility Rij. It's such utility that level that the consumer I is indifferent between obtaining this utility Rij immediately and visiting seller J, or just hotel J in my stage. In my model, utility Uij consists of two parts. The first part, this delta ij, is observed by consumer prior to search, while the second one, epsilon, is observed only after consumer clicked on the hotel, incurred some search cost, and explored hotels page. So when consumer sees the list of the hotels, he knows deltas to all hotels in the list prior to search, but need to incur search costs to learn epsilons. Also, I've shown the paper that the reservation utility might be represented as the sum of deltas and the function of the search cost associated with the hotel. So like that. So I model deltas in accordance to the literature as a convolution of hotels' characteristics. It's important to note that I use random utility model, allowing different consumers have different demand elasticities alpha I and beta I. Variable xi stands for unobserved quality, and size quality is likely to be correlated with the price of hotel. This will lead to the usual price endogeneity problem, which I treat with the standard control function approach. So Ursu in her 2018 paper, using the same data set that I use in this study, shows that the position of the hotel in the list affects only the search cost. So hence, the position of the hotel affects only the reservation utility, Rij, but does not change the actual utility, Uij. So consumers, after they already searched the hotel and decided which one to purchase, they don't care like what is the position of this hotel. In my model, I allow the search cost to be stochastic and follows distribution F with mean mu. With accordance to Ursu paper, the distribution mean, this mu is increasing with hotel position in the list, which defined as Nij. So Nij, that is the position of hotel J in the list, which is presented to the consumer I. And gamma is like a coefficient to be estimated. It's more costly to consumers to search hotels down the list. Hence, the search cost is associated with the position of the hotel rather than the hotel's identity. In such a settings, consumer problem is dynamic and lead to complicated demand system. As a result, each hotel's demand consists of several different purchase paths, whose number increases factorially fast in the number of hotels in the list, making empirical demand modeling and analyzing of firms' behavior very computationally intensive. This is one of the main reasons why it was not done in the literature before. Fortunately, recent findings show that the sequential consumer search model can be translated into a familiar discrete choice model. So Choi, Dai, and Kim in their 2018 Econometrica paper show that consumers purchase the product with the highest, how they call it, effective utility, which is the minimum between the actual utility U that consumer derives from purchasing the product and the reservation utility Rij associated with the hotel J. This results intuitionally is as follows. If the reservation utility is too low, the product is never even explored by the consumer. If the actual utility is too low, the product will not be purchased by the consumer even if examined. Another great result of Mark Gonzalez 2018 working paper shows that by choosing the right distribution of the search cost and the right distribution of epsilons, the part of the the epsilons where epsilon that is a part of utility observed only after the search. So if you pick the right distributions, effective utility W have extreme value distribution. That provides a closed form standard logic demand function, which dramatically decreases the problem's computational difficulty and allows efficiently analyze firms' pricing strategy. Here we can see the results of demand estimation. So I estimate the mean utility parameters and standard deviations due to I use the random coefficient model allow my consumers to be heterogeneous. It's interesting that consumers are very diverse in their outside option and value of location and hotel chains. So some prefer chains hotels, some prefer independent hotels. But what is more important, I got that the position of the hotel in the list has significant positive effect on search cost. It's easier for consumers to explore hotels on the top of the list rather than hotels at the bottom. To provide more informativeness to this coefficient, we can say that moving the hotel one position down the list decreases its effective utility W by roughly $2.5. Now, when we know the demand function, so when we estimated the consumer behavior, I will say, we can estimate hotels' costs. I use a standard firms optimization problem where P is the price the hotel charge, C is the hotel's opportunity cost, and D is the demand function. The price the hotel's charge is observed in the data. The demand function is estimated on the previous step, so I can calculate hotel's opportunity costs. After estimation the cost and the demand, I can run counterfactuals where I compare market results in two situations of common and personalized rankings. Between these two cases, between like the common personalized rankings, only the demand function changes, but the estimated cost stays the same. It's important to discuss how the price the hotel charge affects its demand. There are two effects. First, the price affects whether the hotel will be included in the consumer's consideration set. Due to the platform wants to put on the highest position hotels which provides high utility to consumers, the price increase moves the hotel down the list, increasing the cost of exploring the hotel and reducing the reservation utility. In addition to that, the reservation utility explicitly depends on price through the part of the utility observed prior to search. Moreover, the price also have an effect on purchase probability conditional on the consideration set, since it affects the utility level U that consumer derives booking the hotel's room. Summarizing, price change hotels' demand by affecting the probability of the hotel to appear in the consumer's consideration set, and also the probability to be booked conditional on the consideration set. Now, when we estimate the demand and supply models, or just equilibrium models of demand and supply, we can turn to counterfactuals analysis. So the goal is to compare consumers' welfare under two different ranking mechanisms, the personal ranking and the common one. The approach is as follows. First, using estimation of demand and hotel costs, I solve firm's price and equilibrium game for each of the rankings and calculate market prices. Second, I draw 1,000 of consumers from the estimated distribution of consumer characteristics and simulate their search and purchase decisions. After that, I compare results for two ranking mechanisms. So let's see on some main results. So we discussed above.
You have a minute left, just to give you kind of a time check. Sorry, I have no way of like signaling you the way I normally would.
Okay, so I think it's fine. So we discussed above that there are several effects on consumer welfare. There is a direct effect on consumer utility due to the change in the quality of the purchased product, and the search effect due to the reduction in search expenditures. I find that consumers on average experience 3% direct utility reduction in the platform's applied personalized ranking. So they gain roughly 0.5% due to finding better fitted hotels, but lose roughly 3.5% due to increased transaction price. But what is important is that about 30% of the list price sensitive consumers who do not care about price so much experience actually utility gain. And on the right panel, we can see that the distribution of utility change over consumers, where the dashed line shows the average change. Also, in accordance with the previous research, I find that consumers reduce the search intensity and save an average roughly 1% of their utility. The figure shows the difference in positions in the list of hotels which were booked under the common and personal rank. So here's where I'm going to stop. So let me make maybe a brief summary. The paper is the first attempt to analyze the effect of platforms ranking on consumer welfare in the equilibrium settings, accounting for the supply side for the supply side incentives change. I find that the average transaction price increases, and that fact leads to decrease in the utility of average consumers. However, about a third of least price-sensitive consumers experience utility gain due to better product match and reduction of search expenditures. So, thank you very much for your attention, and I will be glad to answer any of your questions.
Anyone can feel free to unmute and ask as they want.
Hi, just a quick few questions. This is Raluca. I was wondering, so to what extent do hotels set prices? To what extent does Expedia set the prices? Another thing I was wondering about is how can you estimate kind of a random coefficients on the parameters? I think you only observe consumers once, like you observe only search impressions, and you can't link them across consumers. Yeah. Any thoughts on those?
Sorry, I can't hear you very well. So could you please repeat the first question?
Yeah, can you hear me better now? I don't know if
it's better.
I'm on my phone, so that might be an issue. I can type the questions if that's better. Sorry.
Yeah, so
I'll just type the questions because.
Yeah, I think that will be
all right.
better.
Sorry about that.
Andre, I have a question for you. Oh, so Heskey, go ahead.
I wondered a little bit about the outside options. So here the assumption is that everybody stays on Expedia no matter what. That's the universe that we're thinking about.
Yeah, very good question. So I do not model the competition between platforms. And platform is not a strategic play in my model at all. So the outside option for each consumer is just to leave the platform without purchasing any hotel at all.
Okay, can I ask one empirical question?
Yeah, absolutely.
Maybe because of the time limit, you didn't talk much about destination. And I just wanted to know how do you deal with the endogeneity issues? Like I think in the model, the price is endogenous and also the ranks may be endogenous as well because of if it's the personal ranking mechanism, right? Is that true?
Yeah. So the ranking. So the ranking is based on the pricing. So the platform try to do the best job to show the best hotels on the top of the list.
Yeah, because the price
itself,
is if the price is endogenous, then the rank will be endogenous as well, right?
Yeah, but the rank is not. So the hotel itself cannot choose its rank. So that is the platform choose the rank of the hotel, but hotel can have an effect on its ranking, choosing the price.
Yes. So how do you have any specific instruments for both price and ranking?
So for price, I use standard approach. So I use control function approach, but pretty much I use like BLP instruments.
Mm-hmm. Okay, so basically, if I understand correctly, so far the didn't deal with the ranking endogeneity right now, right?
So I'm
gonna cut this here if you don't mind, just so that we stay on time. And
Sure.
I'm gonna have Martin start.
Okay.
But feel free to either email or stay around at the end to ask any further questions. Okay, thank you. Martin, you're free to start.
Okay. Hello, everyone. Thank you very much for having me here. I would like to talk about a project which I co-authored with my advisor Paulo Albuquerque at INSEAD. So in this project, we will be looking at how people search online and how people actually incorporate information provided by past customers. So when you search online, I would like to imagine you to think about your favorite retailer. And this is kind of where you start searching. You see the category page, you see information about the products, typically price, brand, average rating. Of course, you can go deeper in search, and then you can see the dedicated page to a particular product if you click on one of these small icons. At this stage, you read information about the product, and you might see some more photos. So typically, this information is provided by the retailer, and these are kind of technical details, like related to the size of the product or any aspects and details about, let's say, whether it has an allergy filter, if we are talking about vacuum cleaners, or what are the dimensions of different parts. But of course, very importantly, you have access to customer ratings for this very item. And this research is about how this option that actually you can read customer ratings modifies your search strategy, if modifies it at all. So the contribution of this paper is that we propose a model of sequential search in which consumers can search for two types of information. One is provided by the retailer, and one is provided by past customers, and these are the product ratings. And of course, people can have the option to purchase an item. And substantially, we will run two counterfactual scenarios and analysis. In one of the counterfactuals, we will investigate what if the website design was such that the most recent reviews are easier accessed, are accessed easier than currently. And second, we will estimate the model where there are no search frictions, and what would happen in that hypothetical scenario. We have data from a British retailer of vacuum cleaners, and very important, we observe what people searched for, what products they clicked to see more information, where did they decide to scroll down to the bottom of the product page where reviews are accessible, and we actually observe what they purchased. So just to clarify, I would like to give you a little bit more detail about how the website looks. This is not atypical at all. Like most US retailers also have this sort of design currently. And so if you click on a product, on the top of the product page, you see more information about the product, more photos. But very importantly, at this stage, you have no access to individual customer reviews. To access these customer reviews, you have to scroll down with the mouse. So now we are talking about PC users. So you have to scroll down like 4 or 5 times, which has its cost. Of course, it also has its benefits because research shows that the most recent ratings provide additional information about product quality over the average rating. So we model the utility of the consumer as an expectation. Of course, you don't really know how satisfied you will be with the product while you are browsing. You will only learn that when you actually get it delivered and you use it. And there are basically 3 main parts that go into the utility function. The first is you related to the information on the category page, such as price and brand. You know, people know it upfront when they start searching, or even before starting searching for individual products. So they know it when they open the category page. There is information accessible when you click on a particular product, and you can read about allergy filters and dimensions, and you see more photos. So the way we model this is very typical how it has been modeled in the past. So this is kind of the Weizmann setting of when there is normally distributed shock when you realize these photos, and people search for products that have good shocks, and that they will be happy if they find a product to their liking. But the contribution of this project is related to the third row of this equation, and is related to how people form the expected utility based on information provided by past customers. These are the ratings. And to give you a little bit more detail on this, let me show you a few more slides of how we actually imagine that this actually feeds into the utility. So experiential quality, this QIJ, is a discrete random variable that is only realized upon usage. I mean, I can have a different experience than you, even if you buy with the same vacuum cleaner. Hence, this is subjective to the individual. And it's discrete because it's convenient to model such a way, and takes value 1 that relates to the worst experience, and capital K that relates to the best experience. And fundamentally, what motivates people to search for products, for product ratings, are two things. So first, just like very similar to the Weizmann setting, when people see great ratings, they receive a good shock, and they might buy that product because that it has a higher utility than the one basically they currently have or found in the past. So this is the first part of the motivation. And the second part of the motivation behind reading more customer ratings is to decrease uncertainty about the distribution of the quality levels you might get if you buy that product. Because people don't really like to be uncertain, not knowing the distribution of this quality, so they go and check more product ratings, with which they can reduce their uncertainty about product quality. So the experiential quality follows the categorical distribution. So basically, there is a probability pi 1 that you will experience a quality level 1, and there's a probability of pi capital K that you will experience a great satisfaction, the highest quality possible. But of course, while you are browsing, you don't know this, let's say, set of pi values. But you actually form you form assumptions about these pi values. And the way we model this belief about the distribution of the different probabilities is via a Dirichlet function, Dirichlet distribution. So basically, the Dirichlet distribution has this alpha, let's say, hyperparameters. And if the researchers knows these hyperparameters at any stage during the consumer journey, that is, knowing these alpha values is sufficient to characterize the current belief of the browsing consumer at a given stage during search. So these alpha values get updated as search proceeds, and when the product ratings are sampled. There are two important things I would like to highlight here is that the model operates with forward-looking consumers, which means that people anticipate how this evolution of belief might happen. So to give you a very simple example, if you are looking at a product that has a 5.0 average rating, you know that even if you scroll down, all the ratings will be 5 stars. So basically know the probability of this alpha. But this is not the case if you look at the product that has a 4.5 average rating, because when you scroll down, you might see 5 stars, or you might see 3 stars, 2 stars. So that's one aspect of the model, which is new. And the second is that we actually run another online experiment to initialize these alpha values. So what I mean is initial values, when you are looking at the product, you know the number of reviews the product has and the average rating. You already have a belief about how the quality of this product might be and how your satisfaction might be when you purchase the product. And I am happy to talk about it when we have more time, but for now, let's just go to the results. And okay, so to get the results, we build on Keller and Oldale 2003 paper where they actually showed that this very setting, which is a sequential search problem, is actually a special case of a multi-arm bandit problem, which means that we can use the reservation value principle very similarly to it has been used in the past in the sequential search literature. And we derive the likelihood by taking a recent working paper of Jung et al. And we had another option that actually people have the chance to go and see the most recent reviews on the bottom of the product page. And to speed up the estimation process, we use ADAM and we use multidimensional interpolation techniques to actually make this process feasible. And when we estimate the model using our clickstream data on vacuum cleaners, we notice that people really care about the quality of the product. So it's important to the consumer to make sure that they are buying a product that is high quality. But we also find evidence that there are significant search costs when people search for two types of information. And we can use these estimated values, coefficients, to analyze counterfactual scenarios. The first counterfactual we analyze will be a little change in the website design. So just to remind you, currently the website displays retailer provided information on the top of the product page, but does not show the most recent reviews at this stage, because those are only accessible at the bottom of the page. But you can imagine an alternative website design when the most recent ratings are already displayed on the top of the product page. So what would happen if the design was such this? We observe a couple of things. So in total, the search costs shrink because consumers don't have to scroll, which kind of leads to an increased consideration set. And because consumers now don't have to pay a search cost, which is gone to read the reviews and make sure that the product they are buying is great quality and be certain, and that they can be certain about it. They can pay this to the retailer actually. So we observe that the price of the purchased product increases. And we also observe another interesting pattern is that people shift their attention from top-rated products, products that have a 5.0 or close average rating, to products that have moderate average rating. And why does it happen? So this is due to the property of forward-looking consumers. Because if you think about this as a signaling game, like think about the current website design. The current website design requires products with moderate average rating to have a costly signaling about their quality. So people have to scroll down and read their reviews because these are not accessible on the top. But top-rated products have no need to signal because everybody knows that if they go down, they will see just 5 stars. So this creates, under the current design, this creates an advantage to top-rated products. But if with this modified layout, this advantage is gone, everybody can signal for free, provided that people click on the product page, and which actually modifies the sales distribution. And we see that products with moderate average rating are going to sell better. And second, we run a counterfactual analysis when there are no such frictions at all. You know, you can think about that. What would happen if there is a perfect AI-based personal shopper? She knows all your preferences and actually makes the search and purchase for you. So under this hypothetical scenario, we observe that the retailer revenue significantly increases, but also people are better off because they actually find the product much more to their liking.
Just so you know, you have a little bit under a minute. So warning.
Great, thank you. And this is my last slide, actually. What we wanted to achieve in this project, we wanted to develop a sequential search model in which people search for two types of information, one provided by the retailer and one provided by past customers. And of course, we wanted all this happen under the presence of search cost. And substantially, we found that a little change in the website layout can change the search outcome and the purchase outcomes, because if moving reviews from the bottom of the page to the top of the page, we see that it increases the consideration set size, and products with moderate average rating become more attractive. And we also estimated a second counterfactual where we check what would happen in a world with no search frictions, and we see that consumers actually are better off, and the retailer revenue also significantly increases. Okay, that's it. Thank you for your attention and having me here, and I'm very happy to answer all your questions in the remaining 5 minutes.
So I'm going to ask basically the same question. The outside good here, could you tell us a little bit more about that? And in particular, I'm worried about showrooming and that the value of the outside good changes as you change the layout.
The value of the outside good that doesn't change with the changing of the layout.
I understand that's what's happening in your model, but I'm suggesting that if what some people are doing is showrooming from this platform, then it might.
I'm sorry, I'm not sure I understand the question or the suggestion.
So there may be people who are on your platform learning about vacuum cleaners and buying them somewhere else. If they learn more about the vacuum cleaners on your platform, that might affect their value of buying somewhere else.
Yeah, that's so we do not model what they do when they leave the platform and go to another retailer. We don't have data on that. So we are constrained in that sense to focus on this particular retailer.
I have a quick
Can I
question, which is that what about herding behavior? So I don't know whether that's in the model or probably not, but like if you show more information, then customers may like herd. Like, I mean, the more information you show, the more likely there is herding behavior, right? Probably, maybe not, but that would be my sort of idea. Like,
can you give me an example of what you mean on herding behavior?
Like customers may not even, like the more information you see about a product, the more likely people will like sort of go to the more popular product already. And also if you show previous reviews easier than when you write a new review as a customer, maybe you are influenced by the other. Oh yeah, really, I missed that. That wasn't the first thing I noticed about the product, but that's important as well. So maybe I don't know, maybe that's not, but I think that may be something to at least think about, at least to mention the literature.
Yes. No, it's a great point. I think about herding behavior now, we actually observe that when they see more information, like easy access to information, they shift away from the popular products because of signaling gets like sort of easier. This is what we observe.
So you get kind of the opposite, but for a different reason.
Yes, but no, it's a good suggestion. I will have a look at this literature. The second is, so we assume that people have a certain experience with the product and they are honest in the evaluations, that this is not influenced by what they have seen on the website. So it's based on their true experience when they use the product.
Oh, can I ask So I believe that, at the end, you mentioned that, in the without search frictions, the revenue, the sellers revenue are going up. So
Yes.
so I thought that you are fixing the prices.
It's because people, so it's twofold. A minor part comes because people pay a little bit more for the product they actually buy on average, but the biggest so the major part is because more people will buy. So the threshold, like, okay, I don't like this product, and I'm constrained, I only search for 3 products and I don't buy nothing. But when you search for 50 products, because of the distribution of the shock, at some point you get a hydro and you say, okay, actually I am now not buying the outside, not staying with the outside good, but I purchase from the retailer.
So this is about the industry revenue, not about the individual seller.
Yes,
So
yes. If you think of like Amazon, it's about the revenue of Amazon, not the individual sellers there.
I see.
Yes.
So, but as the Andre actually presented, there's going to be certainly this equilibrium effect, right? So if you change this website, it's going to affect the prices. But I understand that that's what you actually did. But maybe in the future, it'll be good if you also can incorporate this
Yes. So in that sense, I'm fixing the prices. Yes, I'm not studying any strategy
here, if you two don't mind, just to keep us on time. Okay, you're free to start.
Okay, thank you for giving me the opportunity to present here. My name is Jarre. I'm a 4th year PhD student at the University of Chicago. I'm not on the job market this year. I will be talking about sequential search models, a pairwise maximum rank approach. This is still a work in progress, so any comment is deeply appreciated. Okay, the question is, we want to estimate consumer preference and search costs in a sequential search model. And why is it important? Because firstly, we want to quantify market frictions due to search costs. And more importantly, we want to recover true consumer preference when consumers only have limited information. And we need these consistent demand estimates to be able to analyze firm behavior in empirical context. For example, their pricing strategy, their sales strategy, their optimal information and platform design. And these combined would give us important implications about the counterfactual consumer welfare and industry profits. So how do we estimate those? The literature has been using the likelihood approach to estimate consumers' preference and search cost with individual level consideration set and purchase data. Now, the likelihood approach can get consistent estimate with a canonical search model, but the canonical models have several limitations. First, it assumes away unobserved product quality that might create endogeneity issue, because unobserved product quality could be correlated with observables such as price, or search cost variables such as position of a product on a search page. Now, assuming these away would of course give us biased estimates. And second limitation is that these models assume that the researchers know the true distribution of match value. So misspecification of these distributions would also give us biased estimates. And these assumptions could be violated in many empirical contexts. So this paper will first adapt a sequential match value search model with differentiated good to incorporate endogenous unobserved product quality and also allow researchers to be agnostic about the distribution of match value. So with the adapted model, the likelihood approach is going to give inconsistent estimates. So therefore, I propose a new estimator, which I call a pairwise maximum rank estimator, that will consistently estimate both the preference and the search cost parameters. And moreover, it only requires data on the search order of one pair of products. Search order here means, given any pair of products, which one does the consumer search first? And this is nice because we don't need data on final purchase or full consideration set as would be needed in a likelihood approach. And this could potentially allow us to apply sequential search models to a more interesting empirical context that we weren't able to due to data limitations. Another advantage of my estimator is that it is computationally light with large product space, and this could happen in many online shopping contexts. And finally, I'm going to apply this estimator to online hotel search in Expedia to estimate consumers' preference and search cost parameters. Now, the empirical context is the same as what Andre just presented in the first part of the talk, so I will not be going through it in my talk today. Okay, so now the baseline model. Consumer A's indirect utility of choosing product J is composed of an observable part. So X is an observed characteristics. An example could be price. And unobserved product quality, Xi, which could create the endogeneity issue. And this is often assumed away in a canonical model. And also idiosyncratic unobserved taste shock to consumer prior to search. An example of this could be a recommendation from a friend. So before consumers start searching, they know the observed quality, the unobserved quality, and the idiosyncratic taste shock. The only thing they don't know is the match value epsilon. So to review this match value epsilon, the consumer has to pay a search cost C, which is the exponential of some search cost variable Z and some search cost parameter gamma. An example of search cost variable Z in an online searching context, it could be position of a product on a search page. In an offline searching context, it could be distances to stores. So after consumer pay the search cost to review the match value, they can decide whether to continue or stop searching. And the endogeneity concern here is that the unobserved product quality Xi could be potentially correlated with observed characteristic X or search cost variable Z. An example would be higher quality products are more likely to have higher prices or be positioned higher on a search page. Now notice here that I'm allowing the unobserved product quality Xi to be arbitrarily correlated with X and Z. I'm not putting any parametric assumption on the distribution of the unobserved product quality. And finally, I'm assuming that match value epsilon follows a distribution F. The consumers know F, but the researchers does not know F. So researchers here are agnostic about the distribution, the true distribution of the match value F. Now, before we talk about optimal strategy, we need to compute the reservation utility R. So the reservation utility R of a product J is computed by equating the marginal cost of searching this product and the marginal benefit of searching this product on the right-hand side. Now, with the change of variable, the marginal benefits of searching this product could be written as the second line here. This is just integrating over the true distribution of the match value, because from the perspective of the consumers, the match value epsilon is the only unknown to them prior to search. And I'm going to define the marginal benefit function as a function G. Now it's obvious that G depends on F. If we don't know F, then we don't know the form of G. But I show in the paper that G inverse exists and is strictly decreasing if F is strictly positive on the domain of G. Now this encompasses a wide range of distributions. Now in particular, the distributions that I know of that are assumed in the literature satisfy this assumption. So if you want to do a likelihood approach, you need to know the form of G to be able to compute the reservation utility R. But my estimator only needs G to be monotonic. And this is where the robustness to misspecification of F comes in. So now we can write the reservation utility as a function of the search cost. So G inverse, we don't know what it is, but we know it's strictly decreasing. And observable quality X beta, unobserved product quality Xi, and a taste shock eta. And the optimal strategy, the selection rule is the consumers are going to search in decreasing order of reservation utility if these products are searched. And these could be translated into an outcome variable that we could observe in the data, which is search order. Now, how is search order defined? For any product pair, I and J, I'm going to define the search order S of a consumer A on product pair IJ to be 1 if the reservation utility of I is larger than the reservation utility of J. So for the consumers who actually searched either I or J or both of them in the data, I would be able to observe their search order S to be 1 if they search I before J and 0 if J before I. And I'm going to call these consumers big A. So now we as researchers, we observe for everybody in this set, the outcome variable search order S, the search cost variable Z, and observables X. And the question is, we want to estimate consumer preference beta and search cost parameter gamma. So the first step would be to replace this reservation utility with what we have just derived here, this equation. So here it is. What's in the indicator function now is just the difference between the reservation utility of product I and the reservation utility of product J. So we have the difference of the search cost part between I and J. We have the difference of the observables between I and J. So XAIJ here is just a shorthand for XAI minus XAJ. And we have the difference of the unobserved product quality of this product pair. We have the difference of the taste shock of this product pair. And the idea is I'm going to pick two consumers, A and A tilde, with the same Z's. So now the consumer with the higher X beta is going to have higher outcome variable S in expectation, because both of these consumers have the same product unobserved product quality Xi, and the taste shock eta is distributed IID for these two consumers. Similarly, if I pick two consumers with the same Zi and same X, then the ranking of CJ gamma would be able to predict the ranking of the outcome variable S in expectation. If I pick two consumers with the same ZJ and same X, then the ranking of ZI gamma would be able to do the job. So therefore, the true parameters would make correct predictions about the ranking of the outcome variable most frequently. Because if I put in a wrong beta here, then it's not necessarily consistent with the ranking of the observed outcome in expectation. So therefore, the objective that we're going to maximize, so this is the objective, it is just the frequency of correct predictions. So I'm taking any pair of consumer A and A tilde with the same Z's, and I'm going to count a correct prediction if the ranking of X beta between these two consumers is consistent with the ranking of their outcome variable S. And I'm going to count both ways. The second line is I'm picking two consumers with the same Zi and X. I'm going to let ZJ gamma do the ranking. Third line is I'm picking two consumers with the same ZJ and X. I'm letting ZI gamma do the ranking. And I have a theorem in the paper that shows the estimator that maximizes this objective is strongly consistent for consumer preference beta and consumer search cost parameter gamma. Now I call this the ideal estimator because if Z is continuous, then exact matching almost never happens. So what I'm going to do is I'm going to replace it with a kernel smooth function on the difference of the Z's adjusted by a bandwidth. So the idea is the consumer pair with more similar Z's are going to have higher weight. The consumer pairs with very different Z's are going to have very low weight. And I have a theorem in the paper show that the smooth version of this estimator is also strongly consistent. And before I conclude, I want to talk about some interesting extensions of my estimator. First, it can be used to non-parametrically estimate the G-inverse function. And these estimates can then be used to test for a true match value distribution in the data. And this is nice because this could give us a sense of how reasonable our assumptions of the match value distributions are in an empirical context. And secondly, it could be extended to allow for heterogeneous preference and search cost parameters under various scenarios. And thirdly, it could be extended to the case where search cost variables also enter utility. And last but not least, it could be extended to a sequential price search model. So to conclude, you should consider using my estimator in sequential search models if there is concern about endogeneity, or if there's no sound microfoundation for assuming a particular distribution of match value, or you don't observe final purchase or full consideration set data, or that your product space is very, very large. And these unfortunately could happen in many empirical contexts that are interesting. So the takeaway is my estimator allows us to apply sequential search model to a wider range of empirical contexts that could be potentially interesting. So that's all I have for today. Thank you.
People are free to ask questions as they have them. Have you thought about any, like, call it nice data sets you could take this to test how this would compare with a different approach in kind of an overly ideal setting?
Yes, the empirical application of this paper is using the data on Expedia hotel search, which is used by Andre and Raluca's paper. So the simulation results show that so first the simulation results show that my estimator in terms of mean squared error or bias are doing much better than the likelihood approach. And in the empirical application, the estimator on the estimates on the effect of the ranking on search cost is very similar to what Raluca estimates with a random sample, a random ranking subsample of the data. So this is, consistent with the fact that I'm dealing with the at least endogeneity of the ranking correctly.
That's great, Jarwei. I just wanted to add one thing, and thanks for a very good talk. I think, yeah, you might want to look at a few other data sets, because from what I remember in the Kaggle Expedia data that we used, you don't observe search order. And my understanding from this estimator is that it matters a lot. I mean, search order matters a lot. And most people only search one thing. So, getting a data set where you observe a lot more searches and the order would be interesting. Well, of course, you maybe wouldn't have the exogeneity of position in that case, but yeah, something to think about.
Yeah, that's a good point. So the search order here, so even if you only observe the consideration set, for example, what products the consumer clicked on, and consumer mostly just click on one product, for example, then if you take any product from the search set and any product from the unsearched set, I will be able to observe the search order of these pair of products, because the one is searched, the other is not searched. So the search one is obviously searched earlier than the one that is not searched. So this would work in a context where you only observe the consideration set data.
Got it.
Thank you. Thank you for the question.
Okay, so we'll cut questions here then, and people can stick around and ask any questions after. Yang, you're free to share screen and start when you're ready.
Okay. Hello, everyone. My name is Yang. I'm very happy to have the opportunity to present my job market paper, Price Transparency in Online Markets. Empirical evidence shows that price dispersion is very common in many homogeneous product markets. For example, if you want to buy an iPhone 12 and you search on Google Shopping, you're going to find different retailers charge different prices. Price dispersion has been studied a lot for the past decades. However, little is known about product and service quality dispersion. For the same example, some retailers will provide faster delivery, and some retailers can give you a free charger or free headphones, since iPhone 12 doesn't include this. To have a more comprehensive understanding of price and quality dispersion has become more important recently because the development of price comparison websites has led to increasing price transparency. However, according to the European Commission e-commerce sector inquiry, price comparison websites mainly focus on price and do not allow retailers to differentiate themselves sufficiently in terms of quality. And the respondent manufacturers of the inquiry have concerns that the decreased price and the margins may reduce retailers' effort incentives to invest in quality, which implies that the welfare effect of price transparency is ambiguous. Let's see an example. You search iPhone 12 on Google Shopping, you are going to see all the prices immediately. However, it's very difficult to see the quality of a retailer. For example, for this group of retailer, basically there's no information about quality. And for this group of retailer, you can see the rating scores. However, they can be biased. And most importantly, for example, Cdiscount. There are many third-party sellers on Cdiscount. So before you click the link, you don't know whether it's the offer from Cdiscount or from the third-party seller on Cdiscount, and you don't know what is the quality. And once you click the link, then you can see, okay, this the delivery time of this retailer is 4 to 6 working days, and the delivery, this retailer provides faster delivery and a 2-year warranty. So the research question of this paper is, what is the welfare effect of price transparency? More specifically, what are the consumer search behavior and the retailer's choice of quality influenced by price transparency? And what are the relevant policy implications? To solve this problem, I modify a canonical clearinghouse model by adding quality into consumer's utility, and I compare two different situations. For the benchmark scenario, there exists a no price comparison website, and the consumers know nothing before searching. And for the price-directed search scenario, there is a price comparison website, and some consumers can use it to learn all the prices before searching. So the main result is the following. I found that for the benchmark scenario, retailers choose the monopoly price and quality, like Diamond 9071. While price transparency leads to lower prices, and a lower price is always linked to lower qualities. Price transparency also increases consumer surplus, but sometimes price transparency can lead to lower total welfare. And interestingly, price transparency sometimes leads to no price and quality dispersion, which means that there is a pure strategic equilibrium. Okay, if I have time, I will also talk about the policy implications later. Okay, now let me give you more details about the model. There are more than 2 retailers and 1 unit of consumers. Retailers sell homogeneous products, and they compete on both price and quality. Quality is a function of effort, is negative, increasing, and concave. Per consumer margin is P minus E, which means that the cost of effort is linear and equals to the effort itself. For consumer, the valuation for the product is distributed on the interval from 0 to Vmax with the distribution F, big F, and the net surplus is the valuation minus price and plus the quality. So note that what consumers care about is the adjusted price, which equals to the price minus the cost. There are 2 types of consumer. Fraction lambda of them are non-loyal consumers, and 1 minus lambda of them are loyal consumers. Each retailer share loyal consumers equally. Loyal consumer will only visit a designated local retailer, and the search cost is free. Non-loyal consumer, they can visit any retailer. The cost to visit the first retailer is 0, and the cost to visit any other retailer is S, which is positive. And also, I also assume there is a free recall. Note that loyalty and the valuation B are independent. The timing is the following. At t equals to 1, retailers choose their quality and the price simultaneously. At t equals to 2, loyal consumers visit their local retailers to learn the price and quality, while non-loyal consumers, they can visit any retailer and they search sequentially. Like I said before, I will compare two different situations, the benchmark scenario and the price-directed search scenario. So now, first, let's talk about the benchmark scenario. Let pi denote the per consumer profit function. So this part is the per consumer demand, and this is the margin. And let PM EMAM denote the monopoly price and effort. And let E star denote the efficient effort, which maximizes the surplus of quality minus the cost of effort. I found that the monopoly price and quality are unique, and also monopoly effort is efficient, while monopoly price solves the first order condition. To understand why monopoly effort is efficient, we can rewrite the per consumer profit function as a function of adjusted price and effort. Then we can see that by choosing the efficient effort, retailer can obtain the highest margin while keep the per consumer demand unchanged. So we find that there exists a unique equilibrium where all the retailers choose the monopoly price and the quality. They share non-loyal consumers equally. The second part comes from the tie-breaking rule that if consumers are indifferent, they randomly visit a retailer. So the first part, the intuition for the first part is similar to that of a diamond. Retailers have an incentive to deviate if they do not choose the monopoly price and the quality, because consumers will not leave and search again due to the if they see unexpected price and quality due to the search cost. So now let's move to the price-directed search scenario. In this case, non-loyal consumers can see all the prices before searching. So which means that this is the signaling game. And the first thing we need to do is to find a reasonable way to describe consumers' beliefs about the unobserved quality given the observed prices. So for example, if a consumer sees listed price 700 and 710 euros for iPhone 12 from different retailers, which one should the retailer accept to be better? So to solve this problem, we are going to follow an idea summarized by N and Wright. Consumers should be wary enough to think about what efforts would be optimal for the retailer given the observed price and given all other players' equilibrium strategy. We found that the belief both on path and off path of a retailer's effort is uniquely pinned down by its price. And let EWP denote the belief, we found that this is the effort that maximizes the per consumer profit for the given price. The property of expected adjusted price is summarized in the following lemma. I'm going to explain this by this graph. If price is below P tilde, then the price is too small. So which also means that the margin is also very small. Then for retailer, it's not profitable to make positive effort to increase the demand because the margin is too small. So which means that in this interval, the effort is zero. So that's why the adjusted price is linear. And then for P above P tilde, there are two different situations. When retailers cannot improve quality easily, such that Q prime 0 smaller than Q tilde, then quality doesn't have a lot of effect on consumer anyway. So adjusted price is mostly decided by the price and is monotone in price. However, if retailers can improve quality very easily, then but they didn't because the price is very low, then in this interval, when they provide the positive effort, it's gonna have a very big effect on consumers' utility. So in this interval, retailers are going to believe consumers are going to believe a retailer with higher price provides higher surplus, which means that they think you get what you paid for. However, since the quality is concave, then finally the effect of price dominates the effect of quality again, and the adjusted price is increasing again. Then we are going to talk about the equilibrium in these two situations. First, in this situation, when retailers cannot improve quality easily, the equilibrium is similar to that of variance model. So let's focus on the more interesting case is when retailers can easily improve quality. So there are 4 types of equilibrium, which depends on the fraction of non-loyal consumers. Note that lambda is a fraction of non-loyal consumers, and also depends on the curvature of a quality function. So I'm going to explain the equilibrium by the graph of expected adjusted price. So at first, if the fraction of non-loyal consumer is very low, then we know that retailers are going to focus on their loyal consumers. So they are going to choose price close to the monopoly price. And so like we can see, sorry, I didn't remember, I didn't mention the red line is the equilibrium price support. So we can see it's close to the monopoly price. And as lambda is increasing, retailers are going to choose the lower prices. And then at this point, they cannot choose a lower price. They cannot choose a price lower than tau, because consumers think you get what you paid for in this interval. So choose a price lower than tau. You lose non-loyal consumers, and second, you decrease your per consumer profit. So instead of choosing a lower price, what they do is that they choose the price tau with a positive probability. And as lambda keep increasing, there are 2 different situations. And first, retailers are going to choose price tau with probability 1. And this is what I mentioned before. There exists a pure strategy equilibrium. And sometimes retailers are going to choose a very, very low price to attract non-loyal consumers. So whether it's this case or this case depends on the curvature of the quality function. Okay, now let's make some welfare analysis. We will, like before, we will also explain it by an example, because as we know, the equilibrium is a mixed strategy equilibrium, and it's very difficult to see what is the total welfare. So we assume V is uniformly distributed from 0 and 1, and Q equals to A times 1 minus E squared. TWPD is the total welfare of a price-directed search scenario, and the TWM is the total welfare of the benchmark scenario. As we can see, TWM is constant for any lambda. Well, when A is small, it means that retailers cannot improve quality very easily. So quality doesn't make a lot of difference. And the equilibrium is similar to variance. So that's why total welfare is increasing in lambda. But if A is large, which means that retailers can improve quality very easily. There are different situations. well, we can see the total welfare can decrease, and it can even be smaller than the total welfare in the benchmark scenario. So another thing we can observe is that no matter what the shape looks like, at first the total welfare is in the press directed search scenario is always increasing.
I'm sorry to interrupt, just so you know, you've got about a minute left.
Okay, sure. I'm going to finish soon. So the following proposition summarize the welfare effect of a price-directed search scenario. First, price transparency can lead to higher consumer surplus. And this is because the retailers are willing to choose better offers to attract those non-loyal consumers. And second, price transparency leads to higher total welfare when the fraction of non-loyal consumer is small enough. This is because when lambda is small, prices and efforts are close to the monopoly level. So it has more effect on consumer surplus, but less effect on the industry profit. And we find that price transparency sometimes leads to lower total welfare. This is because price transparency sometimes leads to too much price competition and reduce retailers' incentive to invest in quality. And the efficiency loss is so large and such that the total welfare can even be lower. Okay, I guess I don't have time. I will stop here. Thanks.
Thank you. And I'll open it up for questions. After we hit the 35 mark, I'm going to cut it, end the recording, but I will leave the room open. Anybody's free to ask.
So any questions or comments?
Yeah, I had a small question on the bit I think is very interesting, and you had some difficulties with analytically solving because of these mixed strategies. I know in your calibrated example, you picked a duopoly, you picked n=2 to try and make things a bit easier. If you do that, sometimes these mixed strategies become analytically much more simple. Can you make an assumption on n, which doesn't seem to be a comparative static you're very interested in, and then get analytic results? Normally duopoly or triopoly does the trick.
Yeah, that's a very good question. So actually this the result of this graph comes from simulation of this example. And here actually I didn't see, but I assume n=2. But still in this situation, it's still very difficult to get some analytical result. I still need to use Mathematica to simulate the equilibrium and get these graphs. Thanks. Any other questions?
Okay, I'm gonna end the recording here. Thank you everyone for coming. Thank you to the presenters and thank you to everyone who asked questions. I'm gonna end the recording here, but leave the room open.